In this video, we're going to talk about sketching piecewise functions. What we have here is a piecewise function, and this is what they will usually look like. And it's essentially just a function that has three different pieces based on these particular conditions. So if we take a look here, what we have is that f of x is equal to negative x if x is less than or equal to 0. F of x is equal to 9 minus x squared if x is greater than 0 and also less than or equal to negative 3. And f of x is equal to x minus 3 if x is greater than 3. Now when it comes to graphing a piecewise function, a good step to take here is to kind of create a table of values that we can determine based on points that we pick that go along with these conditions that are present here. The first point you always want to pick is your endpoint. Your endpoints are here. This is an endpoint. 0 and 3 are endpoints. And 3 is an endpoint. So let's start with this function here, f of x is equal to negative x, and we're going to start with our endpoint of 0. If I plug 0 into this function, I will get negative 0, which is just 0. From this, I get the point, x, my xy point is 0, 0. Okay? The next thing that you have to determine here is if this point is an open circle or a closed dot. What this means is, what we're basically saying with that is this point part of the function? And because this includes this equals to line here, we're saying that x can in fact equal 0 here. So when x equals 0, it is part of this domain here, okay? So that means that this is a closed dot, and I'm going to abbreviate that with a C. We know this is linear. We want to pick a second point here that satisfies this, that is in the domain of this part. And something less than or equal to 0, well, that can easily be negative 1 because that is less than 0. If I plug negative 1 into this, I get positive 1 because it will be negative 1. So the point I get for this one is negative 1, 1. This is my x value, this is my y value. Now remember, this point is not an endpoint, so we've strategically picked this one. It is in the domain of this piece. So these ones will always be closed dots. Let's go on to this function now. We want to start with the endpoints. Okay, so we're going to start with 0. Now, if I plug 0 into this, I get 9 minus 0 squared, if I plug 0 here. And that is equal to, 9 minus 0 squared is equal to 9. I get this point here of 0, 9. Now let's closely pay attention to this. This 0 that we're plugging in is not in this piece's domain. X has to be greater than 0, but that doesn't include 0. So because of that, this one gets an open dot, an open circle. It's not part of that piece. We have to include it when we're figuring out our tables of values because it's one of these endpoints, but it is not part of this function. It is not in the domain of this piece of the function. We're going to do the other endpoint, which is 3. Now when I plug 3 into this, I get 0. Because 9 minus 3 squared is 9 minus 9. So this point I get here is 3, 0. Now this one, unlike the one we just did, this 3 is part of this domain. So that means that it is included in this piece. This one gets a closed dot. Now because we can look at this and tell this is a parabola, okay, we really want to have 3 points for this. A good way to do these types of problems is if you have one of these that has 2 endpoints, it's always good to check one in the middle as well. So why don't we check f of 1? And the reason I'm picking 1 here is because 1 is in between 0 and 3. You could also have picked f of 2. That would have worked just fine. So when I plug 1 into here, I get 9 minus 1 squared, which is 8. So that'll be another point that we get, 1 comma 8. 1 comma 8. And this is also closed because it's within the domain. All right. Okay, we got one more piece to work on before we can actually start graphing this. So let's check this function out. Again, we're going to start at this endpoint of 3. If I plug 3 into this, I get 3 minus 3, and that's just 0. Okay, so I get this point 3 comma 0. Checking this function here, this domain of this piece does not include 3. We have to plug the endpoint in, but it does not include 3, which means this point is open for this piece. It does not include 3. What we want to do now is pick another point which is in this domain, and 4 is a good candidate. 4 is greater than 3, so we will pick 4. You could also have picked 5 or anything larger. Plugging in 4 into this, 4 minus 3, we will simply get 1. And this point would give me 4 comma 1. Okay, and this is closed because it is in this domain. Well, now that we have these tables of values, let's go ahead and make some room here and draw this graph with this information on it. Okay, so what I've drawn here is a graph. Each tick mark here is scaled to equal 1. What we're going to do is we're going to plot these points that we found and draw our graph. Let's start with these points here. We have a point at 0, 0, and that dot says that it's closed. That point says it's C, which is a closed dot. So I'm going to draw a dot there at 0, 0. So I've done this one. Next, I'm going to draw this one at negative 1 comma 1. So negative 1 comma 1. What I can tell from this, since this is an endpoint, I can go ahead and connect here. This is going to be a straight line. I can tell that because this is just a linear function here. So I knew I was going to get a straight line from that. Let's take a look at this one here. We got our first point at at 0 comma 9. So at 0 on the x, we'll go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now this one is an open circle. Hopefully you can see that. It's open. Okay, it's an open circle. And our next point we have here is 3 comma 0. This is a dot. And it looks like our other point is 1 comma 8, which is here. What we know about this is that this is a parabola. So we know it's going to look like a curve like that. And finally, what we have is this one here, which is 3 comma 0 open. So let me check these, by the way. I've done all 3 of these points. And what we have here is we have a point 3 comma 0, which is open here. So let's go there. And when we go there, let's notice something. There's a closed dot there. So what do we do with that? Well, this brings up a good point. If I were to make this an open circle here, it would already be filled in with the dot. So basically I can just leave this alone. This point is defined here, but it's just defined with this piece. It just so happens that these pieces connect to each other. Okay, now let's look at the next point. We have the point of 4, 1. So that's here. And that is a straight line. Okay, so let's just take a close look at this graph. What we have is we have this piece here, which is f of negative x from 0 and everything below. What we have is we have from 0 to 3, we have our piecewise function that's the parabola, and then from 3 on, we have this linear function here, x minus 3. Hopefully that clears that up and gives you an idea of how to graph piecewise functions.